So I think we should go back to the whiteboard. Um, can you draw on the whiteboard?
Excuse me?
Can you draw on the whiteboard?
Um, yes.
Okay, okay. So now we're gonna go into Ohm's law. Now, Ohm's law is not that, what can I say? It's not that complex of a law, and it's basically just one equation that you're gonna use over and over again. But since this is physics, you're gonna implement it in different ways depending on the scenario or the circuit that you are given and the questions that you are asked. So Ohm's law states that, what can I say, between 2 points, uh, the potential differ the actually let me just stop that. Ohm's law states that the current of a conductor, the current that travels through a conductor between 2 points, is directly proportional to the voltage across those 2 points and inversely proportional to the resistance of that conductor. So what it states is that when you have a wire like this and you're gonna have like these here, so the current between these 2 points and this wire, let's say the blue one is our conductor and these are just I I just that indicate the points we're talking about. The current which is traveling between these 2 points, and for current we use the symbol I. We don't use the symbol C, we use the symbol I. The current traveling through these 2 points is directly proportional to the potential difference. And to show direct proportion, we use this symbol, and our potential difference is the EMF, which is the voltage. But this current is also inversely proportional to the resistance of the conductor. So basically, this current is directly proportional to the voltage and inversely proportional to the resistance. And what that means is that when the voltage between these two points increases, when the voltage increases, let me use a different color for that. When the voltage increases, the current will also increase. But inversely, when the resistance of the conductor increases, the current is gonna decrease. So that's what we mean by directly and indirectly or inversely proportional. So when we say things are directly proportional, when one increases, they both increase. And when we say things are inversely proportional, when one increases, the other one will decrease. So from this, we can now develop an equation in which we can say current is equal to voltage over resistance. And that's Ohm's law. So when you take Ohm's law as a statement, you can end up with this equation, or you end up at this equation. But if you just write the formula down, obviously, sometimes you write it as R is equal to V over I, but more popularly, you write it as V is equal to IR. So when you have a when you have an Ohm's law question, you can either use any of these equations. It's basically the same equation, just written in different ways. And now we're gonna go into, I think this is basically it for Ohm's law because it's a fairly simple equation. I think the difficult part when it comes to Ohm's law is the calculation part. But either way, um, since we're gonna move forward into questions after this, do you have any questions or anything to add onto what I've already given you? Or is there something you don't understand?
No, I understand.
Okay, so you're fine with everything, no?
Yes.
Okay, so now we're gonna, we're gonna do, I'm gonna share my screen and we're gonna do a couple of questions. I think we only have enough time for like one or two. So we're gonna go back to that question that we answered. And as you can remember, our equivalent resistance was 12 ohms. And now they say we should calculate the reading on voltmeter 2. So first thing we must do is go to our diagram and look at voltmeter 2. So we know that voltmeter 2 is connected to an 8 ohm resistor. So they say the switch is closed now. So what we can first do is we can apply Newton's, sorry, why do I keep saying Newton's? We can apply Ohm's law and find the reading on ammeter 1. And if we find the reading of the current traveling through the entire circuit, we can find the reading on this voltmeter by multiplying it with that. So we have our equivalent resistance, and we also have our overall voltage traveling through the circuit. And now when applying Newton's second law, we know that I is equal to V over R. And our resistance is 12, but our voltage is 24. And then we end up with 2 amperes traveling throughout the entire circuit. So when we get questions on circuits, we usually have to solve indirectly. So instead of just going straight up for V2, we have to solve for A1 and then go back to V2. So this is the current passing through A1. Uh, and then now, since we have the current passing through A1, we just take this current and multiply it by this resistance to find the voltage, because we know that from Newton's second law, V is equal to I R. Our I, that's going to be 2 amperes, and our R, that's going to be 8. So the reading on V2, that's going to be 16 volts. Now, there's also a more complex, I can't, like, there's also another method you can use to find this without having to find the ammeter reading. But I think it's better that I explain that method to you face to face than here. Um, or can I ask, maybe I can just ask you like a few questions to see if you'll understand it. So do you understand what we did here? Just
Yes.
okay. So do you understand how ratios work? I think you learned this in grade 9, how how to use ratios to calculate like the total thing. Uh, I think I think she's experiencing motion.